Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Not every network issue is caused by a misconfigured setting or a disconnected cable. Sometimes the underlying cause lies deeper, in optical signal degradation, failing transceivers, overheating components, or overloaded processors. These types of issues are harder to spot because they don't always result in a complete outage. Instead, they manifest as slowdowns, flapping interfaces, or intermittent failures that defy quick diagnosis. But for experienced technicians and exam takers alike, recognizing these deeper hardware and optical issues is an essential skill. Let's begin with one of the most important diagnostics in fiber optic environments, recognizing optical signal loss. When a fiber connection is completely dark, no light, no link, it usually means a physical break or a connector that's not seated properly. But not all problems result in total failure. High attenuation, often caused by dirty connectors, poor polish, or mismatched fiber types, can reduce signal strength to the point where transmission becomes unreliable. Intermittent signal loss is often due to stress or bending in the fiber, sometimes from cable routing or changes in ambient temperature causing expansion or contraction. Several specialized tools are used for optical troubleshooting. An optical time domain reflectometer, OTDR, sends a pulse of light through a fiber and measures reflections, helping locate breaks, splices, or areas of excessive loss. A power meter, used with a calibrated light source, measures the strength of the optical signal received and confirms whether the link meets expected thresholds. For quick visual checks, a visual fault locator, VFL, injects a visible red laser into the fiber, illuminating any points of excessive bend or disconnect. Each tool plays a specific role and is chosen based on the length and type of fiber, as well as the nature of the problem. Transceiver failures are another common source of trouble in optical and copper environments. Transceivers such as SFPs and QSFPs convert electrical signals into optical signals, and vice versa. If a transceiver is incompatible with the switch or incorrectly seated, the link may not come up at all. Dust, even at the microscopic level, can block the light path and prevent proper signal transmission. Additionally, firmware mismatches between transceivers and networking hardware can cause instability or link negotiation problems. These issues can be especially tricky in environments where third-party optics are used, in devices that expect vendor-certified modules. When hardware problems occur, they often show up as performance symptoms before complete failure. Devices may exhibit random slowness, increased latency, or frequent packet drops. High CPU or memory usage can cause queue overflows, dropped packets, or delayed routing and switching decisions. Interface flaps, where a port briefly goes down and then comes back, might signal internal instability or a misbehaving transceiver. These symptoms don't always point directly to the physical cause, but they are warning signs that should never be ignored. Power supply units, PSUs, and cooling fans are too often overlooked but critical components. If a fan fails or is obstructed, the device may overheat and begin throttling performance to protect itself. Many devices will generate SNP traps or syslog entries when hardware alarms are triggered. Some switches or firewalls may blink LED indicators to signal high internal temperatures, fan failures, or power supply issues. Regular monitoring of temperature, fan RPMs, and power draw helps catch these issues before they result in shutdowns or permanent damage. Memory and processor bottlenecks are another area where performance degrades without total loss. When a device's memory usage approaches its maximum, it may be forced to drop packets or offload sessions. Logs may show increased latency, queue overflows, or retransmissions. High CPU usage may result from excessive route calculations, logging overhead, or denial of service conditions. These metrics are typically visible via CLI commands, SNP polling, or performance dashboards. When connectivity seems fine but performance is erratic, internal resource exhaustion is often the cause. Environmental contributors to hardware instability should never be dismissed. Poor airflow, such as blocked vents or crowded racks, can trap heat and slowly damage equipment. High humidity or dust buildup can corrode internal components or clog fans. Even physical vibration from nearby equipment can cause intermittent contact with modular cards or connectors. For environments where uptime is critical, monitoring temperature, humidity, and airflow should be part of your preventive maintenance routine. Rack hygiene and cable management also directly impact airflow and cooling efficiency. Interface-level performance diagnostics often reveal the symptoms of deeper problems. Commands like show interfaces display packet drops, CRC errors, late collisions, and other anomalies that signal mismatches or degradation. Speed and duplex mismatches can occur when one side of a link is set to auto-negotiation while the other is hard-coded, resulting in half-duplex performance or reduced throughput. Buffer overruns and output drops may indicate that the switch or router cannot process traffic fast enough, leading to queuing issues. These conditions often correlate with other hardware or environmental factors that require deeper investigation. Another hidden bottleneck lies in the storage systems of network appliances. Devices like firewalls, proxies, and routers may log events to internal flash or disk storage. When these disks fill up or experience latency, performance suffers. Packet processing may be delayed while logs are written, or log rotation may fail entirely. You might see delayed firewall rule application, missed syslog messages, or crashes during backup operations. Monitoring disk usage, log rotation schedules, and error messages related to storage is essential, especially on multi-function appliances that serve as both security and routing platforms. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. While diagnosing performance issues and hardware faults, one of the most critical steps is ensuring firmware and driver updates are applied as needed. Manufacturers frequently release updates to correct known bugs, improve hardware stability, and resolve compatibility problems between transceivers, modules, and management platforms. If a switch port randomly drops link or a firewall appliance begins rebooting during heavy load, outdated firmware may be to blame. These updates should be scheduled during maintenance windows to minimize disruption, and always preceded by configuration backups. In production environments, applying a fix without proper planning can create more problems than it solves. Hardware logs serve as a primary diagnostic source when troubleshooting deeper hardware or performance issues. Most enterprise-grade devices offer some form of event logging, whether through local logs, syslog output, or SNMP traps. Reviewing logs can help you catch non-obvious errors, like a fan running at low RPM, a temperature threshold breach, or a memory error during boot. In network appliances, commands like show logging, show environment, or display diagnostic information provide direct insight into internal metrics. Always check for recent reboots, error messages, and warning thresholds triggered by environmental or component stress. Identifying faulty hardware components becomes easier when you know what can be replaced and monitored. Many switches, routers, and firewalls support modular components, such as replaceable power supplies, fans, or SFP modules. A fan failure might trigger an LED alert or raise an SNP trap. Some platforms will automatically shut down affected modules to prevent overheating or power instability. Vendor-specific diagnostics tools, like Cisco's Diagnostic Monitoring or Juniper's Health Checks, can pinpoint failing hardware, track voltage and thermal readings, and flag components nearing end of life. This proactive monitoring helps prevent unplanned outages. A common strategy for isolating hardware faults is to swap the suspected component with a known good replacement. For instance, if an optical transceiver is underperforming, replacing it with a functioning spare can confirm whether the issue lies with the module or the fiber. Similarly, if a switch port consistently flaps, moving the cable to another port on the same switch helps determine if the port hardware is to blame. This technique, called swap and test, is simple but powerful. It must be performed systematically, with each change logged for rollback and review. Technicians should document each replacement, test result, and performance change to maintain continuity. Establishing performance benchmarks and baselines helps you recognize deviations early. Without knowing what normal looks like, it becomes difficult to prove that a network slowdown is occurring. Tools like SMP monitoring platforms, interface graphs, and system health dashboards can track metrics over time. Baselines should include CPU usage, memory utilization, interface throughput, and optical signal strength. By comparing current stats to historical norms, technicians can quickly identify degraded performance even before users notice a problem. This is essential for capacity planning, proactive maintenance, and early fault detection. There are times when even a thorough diagnostic effort leads you to vendor support. If you've confirmed that a component is faulty, incompatible, or underperforming, and the device is under warranty, it's time to escalate. Support cases should be accompanied by logs, test results, and any error codes from diagnostic tools. Many vendors will request these before issuing RMAs or offering configuration advice. In cases of confirmed optical incompatibility, such as using third-party optics in a vendor-locked platform, vendor guidance may also help confirm supportability or provide compatible alternatives. Never hesitate to reach out to the manufacturer once internal troubleshooting reaches a wall. The Network Plus exam frequently includes questions about hardware and performance issues. You might be presented with symptoms like packet drops, CPU spikes, or interface flapping and asked to choose the most likely cause. These questions often test your ability to associate symptoms with root causes, such as identifying fan failure from an overheating alert, or tracing poor throughput to a speed mismatch or buffer overrun. Other questions may ask you to select the right test or diagnostic step, such as using an OTDR for fiber faults or checking syslog for memory errors. These scenarios reward familiarity with both symptoms and tools. To summarize, the path to resolving deeper hardware and optical problems begins with visibility. Use the right tools, power meters, SNMP monitors, S-log analysis, and physical inspections to gather evidence. Match those findings against known good baselines and historical performance data. Always confirm whether performance symptoms map to internal bottlenecks like CPU or memory overload. When needed, replace components strategically using known good swaps and log every step along the way. If the issue persists, escalate to vendor support with thorough documentation. The foundation of resilient networks isn't just in good design, it's in monitoring, testing, and proactive response. Fiber, fans, transceivers, power supplies, and CPU loads all contribute to overall network health. When any of these elements fail, performance can degrade silently before ultimately disrupting service. But with the right mindset, tools, and process, you can resolve those issues before they become major outages. Hardware and optical awareness don't just make you a better troubleshooter, they make you a more complete network professional. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.